slope-intercept form of a linear equation?
Y equals mx plus b.
Great. Example 1. The slope is, they said the slope is 3 and the y-intercept is -4. So what's the equation for this line?
Y equals 3x minus 4.
3x minus 4. Very easy. You're just putting m in, you're putting in b, right? All right, now let's do the checkpoint. Number 1. Amy, what is this? If the slope is -2 and the y-intercept is 7, what's your equation for your line?
Y equals -2x plus 7.
Great. And Emily, number 2?
Y equals 2/5 x minus 6.
Excellent. Okay. Example 2. Okay, so now you're going to be looking at the graphs, and you're going to pull the equations off of the graph. Okay. So can you, in example 1, cover up the solution on example 2. I mean, can you tell me what the y-intercept is on that graph? What do you say, Emily?
2.
2. Okay. How are we going to figure out the slope? What do we do to figure out the slope, do you think, guys? What's another way of saying slope? Rise over run. Can you guys figure out what the rise over run is there? Okay, basically you're going to find 2 crisp, nice corners that the lines are going through and do that, and then figure out the rise over run. So what say you then, Hallie?
Wouldn't the rise be 2 and then the run be 2.5?
Yes, close. Okay, but let's do nice round numbers.
Couldn't you do
So double that. So what is it? 4? Yes. So the slope, the rise is 4 and the run is 5. Okay, so now can I write this in slope-intercept form? So that's y equals what?
4/5 x plus 2.
4/5 x plus 2. Okay, easy peasy, right? All right, you guys do 3, 4, and 5 right now of the checkpoint.
Three, 4, and 5.
Mm-hmm. All right, Hallie, what you get for 3?
I got y equals 3x plus 2.
3x. So what did you use as your rise over run?
3 over 1.
3 over 1. I don't know. Let me just check how you did that. Okay, you need to find 2 corners, right? Oops, sorry. So like where it's going right through the middle. Okay, so it's going right through the middle here. I mean, right through the corner here. So what's your rise here?
Oh, I had a
Well, it should be, so this is rise, and that's run, so your run is 3, right? So what's your rise over run?
3 over 2. Oh.
No, it's rise is the vertical.
2 over 3.
Yes.
Oh,
Okay, so for number 1, you should have y equals 2/3 x plus 2. Okay. All right, what about 4, Isaac? What'd you get?
Y equals 1x.
Yes, and we would just say y equals x. Okay. Okay, did you say 1x also?
I didn't figure that one out.
Okay, so what's the y-intercept? It's going through the origin, right?
Right.
So that's plus 0. Okay. What's your slope? 1 over 1. So y equals, like if you said 1 over 1 x plus 0, well, what is that? Y
so it's just
equals x.
Cool.
Okay. We don't bother to write the plus 0. We don't bother to write the 1. Okay. How about number 8 then, Amy? What you got?
Number 8.
I mean, number 5. I'm looking at the wrong one. Okay, 5.
I got y equals 3 over 2x minus 3.
That's not quite the slope. Let me just see
Yeah,
which one you
I think it
used.
was.
Okay, you got to find 2 corners. So that's a corner, and that's a corner.
Oh.
Okay, so figure out what that is. So you guys have to be, you know, if let's say this is your grid system, I don't know. Okay, you're looking for where the line is going right through a corner. So you're picking 2 nice corners, okay? So let's say there's a corner here. So then you're counting the rise is here and there's the run there, okay? So you've got to pick, if you're going like halfway through, like I don't want to pick this as a point, okay? Because it's hard for me to figure out exactly what that is, okay? So pick corners. All right, so what'd you say, Amy, for number 5?
So now I have y equals 2x minus 3.
That's correct.
Is that right?
Y equals 2x minus 3, yes.
Oh, I can reduce that.
Yeah, so that's right. And if you do bigger amounts, you get 4 over 2 or something like that, then you're going to reduce it. Yeah. Mm-hmm. All right, any questions on how to read the graph? Okay. All right, number 271. Okay, Emily, would you read that? Example 3.
Space shuttle landing. The graph at the right models the negative slope of the space shuttle as it descends from 12,000 to 2,000 feet. Write the equation of the line and slope intersect 4.
Okay. All right, so what's our y-intercept there? So this is the space shuttle. It's up at 12,000 feet, and it's going to come all the way down to 2,000 feet. Okay. Where are we we're on the y-axis? We're all in. Why are we only on one quadrant? Because the space shuttle is not flying negative distances. Okay, and it's not up. It's not. Hopefully, it's not. Yeah, and it's not a negative. It's not at a negative height. Okay, so the vertical axis is our altitude. The horizontal axis is our the approach distance. Okay, so what's our y-intercept here? What's B? Look at the y-axis. We're 12,000, and of course they're saying 12 in thousands of feet, so we're just saying 12 right now, I think, for the equation. Okay. All right, now let's figure out the slope of this. Okay, so we got to find 2 little corners here that where it's nice and clear where we are. Well, 12, 0, or 0, 12 is one corner, right? Where's another nice corner that we think we can go through? What are the coordinates of another corner?
28, 4?
Yeah.
Okay, yeah.
One in between
Yeah.
24 and 20.
Yeah, I'd say that's it. That's 28, 4 is it. So 28, 4. So in other words, at 28,000 feet, 28,000 approach, I guess landing, we're at 4,000 feet high is what that is. All right, so we got to calculate the slope, right? So we have one point where it's at 0, 12, and the second point is where? 28, 4, right? All right, so how do I calculate slope? Using these points. Okay, so we'll subtract 4 minus 12 over 28 minus 0. Okay, what's 4 minus 12?
Negative 8.
Negative 8, and then 28 minus 0 is 28. Can I reduce this?
Yeah.
I can reduce it by 4, right? So what do I end up with?
Negative 2, 7.
Negative 2/7. Is our slope, in fact, negative? Yes, because it's landing. It's going down, right? Okay, so can I write this equation now? And we're going to write this knowing that this is in thousands of feet, okay? So y equals what? What's m? Negative 2/7 x. What's b? Plus 12. So this is the equation for the landing of a shuttle.
We didn't crash.
Yeah. Okay, now I want you to do 6, 7, and 8 of the checkpoint. And if you play your cards right, you guys might be done with class today.
Oh wow.
When you're done, look up here and check your work. And then let me know if you have any questions.